Okay. Okay.
Yeah.
Okay. Can you see my slide already?
Yes, I can
Yes,
see
I can, sir.
clearly.
Okay. Thank you very much. Maybe I can start right now, Pak Putu. Okay. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Okay. Today, uh, I am actually would like to share some experience to you, especially for informatics students, in which you are familiar with AI, machine learning, etc. Okay. But in this occasion, I would like to share to you some application, especially for forecasting. And then I do some applications. I will show to you actually how to model and then deliver the application into customer. In this case, is industry or other stakeholders. Okay, there are three here that I would like to share to you. Application for wind wave forecasting, and then tsunami early warning system. This is for inverting. And then the last one is electricity load forecasting. This is for electricity company. Okay, so maybe some of you uh, already know my name, and then maybe some of you already know me, but I would like to introduce to you again. So basically, I would like to share to you to this morning. It's about uh, slightly what is actually a soft computing approach. Okay, AI, machine learning, deep learning, data science, and big data, and then just a few slides, and then I will talk about more deep into application, especially in this case is a application in meteorological and oceanography, or usually we call it as a met ocean. Okay, so maybe I would like to introduce myself. My name is Didit Aditya. So my research topic originally, okay, since 10 years ago, is actually fluid dynamics. So it's about wave modeling and then calculus variation. In this case, is a variational modeling, I call it, and then some numerical implementations. And then just recently, maybe less than 3 years, I work on machine learning, but mainly for application to solve problems related with geoscience. So these are my specific topics actually, machine learning, especially related to the to informatics students, but different than other maybe lecturer in informatics who talk about social media analytics and then natural language processing. In this case, actually, my application is more to the nature, especially for geoscience, like wave predictions, wind prediction, sea level prediction, and then also electricity load forecasting. So my background is actually from mathematics, and then my PhD is also from applied mathematics. Okay, so this is my context, and then other than the, let's say, academic work, I also join usually maybe 2 or 3 projects in a year, especially related with the application wind wave, let's say. So since 2000 and almost 10 years ago, so we are working on climate modeling, especially for wind wave analysis, let's say. Maybe you are familiar with some of these projects like Patimban, Balongan, Giant Seawall, and then this one is a Masela, Blok Abadi Masela, and then Cilamaya, Tuban, and then last 2 years was Kuala Tanjung. And then since 2020, I also work on with PLN, Perusahaan Listrik Negara. We are working on a forecasting of, we are designing a system for electricity load forecasting. that I would like to talk about it slightly in this presentation. Okay, so what is actually a soft computing approach? Usually, in my lecture in master degree in informatics, I talk about hard computing and then soft computing. But in this case, I would like to show you only the what is actually soft computing. Maybe you are familiar with this, maybe not. I think everyone outside the informatics is already familiar with this type of graph. Okay, there are AI, and then inside of the AI is machine learning, and then little bit more advanced is actually deep learning, and then it is a subset also. Of course, you talking about big data, and then there are intersection. Of course, there's data science in which mathematics and then statistics quite related with this one, and then data analytics, and then big data is also connecting with this machine learning or deep learning. Why we call it as it is usually we call it as soft computing. Okay, and then also of course data science is also is not only informatics. I would like to show you also in this presentation also some application that we use, not only mathematics, not only the informatics, but also this this is actually the most matter one, subject matter expertise. Okay, you need to understand what the problem that you need to solve. Actually, this is the most important one. Mathematics statistic, you can hire, let's say, simply hired mathematicians and then statisticians, and then computer software, we can hire programmer, and then machine learning modeler. But this one is actually the most important one, subject matter. Okay, of course this is maybe you saw this several times. I would like to show you, but I would like to emphasize that three application that I'm discussing for the next 20 minutes is actually by using supervised learning, especially for the regression. Okay, so there are machine learning. Of course, there are unsupervised data without labels, and then supervised the data with labels. Okay, so we are trying to make applications of this one. So machine learning, we solve supervised learning, and then in this supervised learning, usually in informatics, there are many cases they are working on classification. But in this case, okay, for the next three cases that I would like to discuss, we are working on regression actually. What is actually regression? You given something input, and then we are actually training an algorithm to guess a target, let's say. So, but the data are labeled. Okay, this one is a regression. Maybe from the point of view of a modeling, okay, this is a knowledge large. These are supported by two pillars. The most important pillar, which is actually theoretical, and then experiment. Okay, usually theoretical is quite difficult, and then experiment is quite expensive to be done. And then there are in the middle of it is actually the third pillar. It is actually modeling and simulations, bridging between theory and then experiments. Okay, for example, this one E is mc square, Einstein. Okay, this one maybe it was founded by 1905, let's say, and then the experiment itself, the real experiment, is actually in Hiroshima, Nagasaki, 1945. Okay, so it takes some time, but the bridging of this one is also maybe we can approach it by using modeling and simulations. Okay, the first example, okay, I call it as an AI-based wave forecasting system. Okay, there you are also in Malaysia. Okay, there are students from Malaysia here. Okay, but mainly in Indonesia, we can see it is a large basins actually of hydrocarbon. Okay, we are quite rich, of course. So you can see it in here. There are drill and then producing basins, and then maybe to be expected in the future. There's quite large basins. Okay, most probably also in the Sea of Malaysia. But to explore this potential of hydrocarbon, okay, there are quite many advanced companies, let's say, that are working in Indonesia. Okay, this is let's say this is some example. This is American company. They are selling the predictions, also prediction and also data analysis along the Southeast Asia like this. Okay, so this is we are actually the big our their big market. Okay, the other company, this one is actually originally Dutch company, and then bought by uh, British company. So this is British and Dutch company. They are also, of course, uh, selling service of meteorology oceanography in Indonesia. And then this is also quite large company from Dutch. This is also they are selling this weather forecasting service, especially for Indonesian. Okay, it's an Indonesian company like oil and gas company. So our aim is actually quite simple. We would like to make like a forecasting system. It is not only accurate, okay, but it is also light. What is light here? It is AI based. Okay, so I would like, before we go to that one, how I would like to share the idea that we are designing the forecasting itself. Okay, this is actually the, let's say, conventional way for to do the forecasting. Okay, the weather is actually simulated by using climate model, and then the wind, it producing the wind. Okay, and then the wind itself, okay, will be added as input for this type of equation. We call it as a spectral balance, spectral we call it as a phase average model. Okay, so this one is actually simulating propagation of energy with respect to in the x direction, y direction, and then rotating. Okay, and then s here is actually sources. So basically this is should be run in the fast computer, let's say in a cluster, let's say in the cluster. Okay, to make prediction of wave. Okay, what about the result? Um, so basically, this is the conventional way or how to do it. Okay, so the result is something like this. Okay, this one is actually the wind. Just if you have a cup of coffee, and then you blow the surface of the coffee itself, it will create some waves. Okay, we call it as a wind wave, a wave that is generated by the wind. This is also the same. This is the wind in the upper left hand side is actually wind that is blowing. This is the cases in Indonesia, and then the lower part is actually we take the input from the wind, and then we simulate it by using phase average model. Then we generated something like this. We call it as a wave field. Okay, why this is actually important? If we would like to take oil or gas, okay, from the earth, okay, but in the offshore itself, we need to build some structure, something like this. And then this structure, of course, should withstand with let's say 100 years. Okay, therefore we need to, let's say, to guess what is actually the extreme wave that occur once in 100 years. So we use statistics, of course, something like this. We call it as extreme value conditions. And then by using statistic and then extreme value analysis, we calculate the return period of the extreme wave. Okay, and then these numbers, and then we give this number to designer of the offshore structure. That is actually how it works. Okay, of course, in the calm condition it's okay, but in the rough condition it can be quite challenging. This is not in Indonesia. Okay, this is maybe in the North Sea, in the eastern part of western part of Europe. Okay, but can be very rough in the sea. Okay, we need they need actually the designer of this one needs extreme value, and then where is the wind blowing in January, let's say February, etc. Okay, they need the analysis, data analysis of these conditions, especially to forecast 100 years ahead. Okay, I back also. I go back to our forecasting system. Okay, this is conventional way. We are simulating by using computer, high-end computer, and then to make because Indonesia is and also Malaysia also, it has a complicated geometry. Okay, we can see it archipelago country. Okay, negara kepulauan. Therefore, the global forecasting system, like from NOAA, GFS, America, US, okay, it is not quite good to represent forecasting in the real complex geometry or something like this. Okay, therefore we need to calculate in the high resolution, something like that, in the upper part. But this one is also by using a computer. Okay, we simulate it. We take the wind and then we simulate it, phase average model, and then it gives this one. Okay, that's how it works. But now to design the AI base, okay, we know it in advance. We would like to replace this process by using deep learning. Okay, how do it work? How does it work? So the wind field is actually, let's say, the process here is actually by simulating, and then it is producing the HS. HS is actually significant wave height, and then it is actually a process, and then we would like to replace this by using a deep learning. Okay, of course, especially supervised deep learning, supervised machine learning, by using for solving a regression problem. Okay, but how do it works? For example, okay, we are working on in Jakarta here, Jakarta Harbor here, Tanjung Priok. Let's say Tanjung Priok, and of course, the wave in Tanjung Priok, we should know in advance where is it the most significant one. Okay, either it is from South China Sea, or from Indian, or from Java Sea. Okay, we would like to know what is the most impactful, the wind that producing wave in the Tanjung Priok Harbor. Okay, therefore we calculate. Let's say this one is actually we calculate the correlation between the wind and the resulting wave in Jakarta, Teluk Jakarta. Okay, and then we introduce something here, spatial correlations. This is also published here, published this year, actually early this year. We are working on this one actually. So first of all, from a point of view of informatics students, this is actually feature selection, let's say, or feature engineering, what we are doing here. Okay, we are selecting from the raw data for the input, okay, which one is the most significant one to be added into our deep learning model, and then to produce the wave. Okay, and these are the results. we are simulating it here. We are working on. We are also investigating it. This is 15 years of data, and then 1 years of data, and then we are trying to forecast 14 days and then 30 days. Okay, so this machine learning is actually processing wind field into wave field, okay, by using deep learning. So the following, we are using 4 models: support factor regression, because we are solving regression problem, and then generalized regression neural networks, and then long short-term memory, because we are working on let's say time series data, and then bidirectional LSTM, bidirectional long short-term memory. And then we conclude that from this publication, we obtain the most significant result is actually correlation coefficient with up to 0.96, and then RMSA, root mean square error, of 0.07 here. We also apply this one as a intellectual property. It is also published at the end of last year. Okay, so we are actually not working only, let's say, for publishing something. Okay, we are also producing software. This software, okay, fortunately, it is also is already being used by industry, shipping company actually. So they are shipping company. Okay, so this forecasting system is used to planning the scheduling. Okay, the scheduling of their tanker. This is not a tanker actually. Like a big ship that is filled in with the coal atau batu bara, ya, coal. And then the location is somewhere here. Okay, this we call this software, we call it as a WFS, or wave forecasting system. Of course, it needs some validation, of course. And then we compare it with some GFS. We compare with other model. Okay, this is a GFS. I'm from US, and then ECWMF from European Union, and then ICON is from Germany, and then this one is ours, WFS. Okay, how accurate is that? So we compare it with the GFS from the US. Okay, here. So the result is actually the following here. The deep learning is we are quite significantly improve the accuracy of the predictions of the significant wave height, and then the peak period here. Okay, qualitatively you can see it in these figures. Okay, therefore we can sell, like, let's say we can sell this prediction into our users. Okay, number 2 is AI based tsunami source inversions. Okay, so before we go into that directions, so I would like to introduce to you the problem here. So this one is actually Gunung Anak Krakatau. Okay, it was actually the last one. Anak Gunung Krakatau was actually blow up. Okay, and then creating some tsunami in here. It is simulated somewhere here. Okay, there are 4 stations that are recording the sea level that is actually also tsunami here. That recording the sea level tsunami during the event. Okay, at Marina Jambu, Ciwanda, Panjang, and Kota Agung. These are the simulations. Okay, of course, this is before before 17 December of 2018, and then this one is after the explosion. Okay, so these are actually collapsed. Okay, but of course the satellite did not recording the the event during the event. Okay, therefore it is quite difficult. Let's say it is quite difficult to redo again to redo the simulations here. Okay, to redo the simulation is quite difficult because why? Because we do not know the process of the initialization of the wave here. Therefore, we would like to build a tsunami inversion, of course, by using a deep learning. Okay, so how can we do it? Because we do not have any data. Okay, we do not have any data. uh, Deep learning always needs data. Okay, how can we build the data? So the data is built by using simulations. Okay, also we are simulating it by using the following wave equations. Okay, and then we create multiple scenarios. Okay, how can we do it? So basically, what we have actually as input for inversion is actually wave that are recorded at these four locations: Ciwanda, Jambu, Panjang, Kota. Okay, and then we would like actually to guess the initial condition in Anak Krakatau. It is also possible to create this inversion also for Palu. Okay, during Palu tsunami, it is actually it happens. We do not know actually the source of the tsunami because it is created by using. It was created by landslide. Okay, the landslide inside of this uh, Bay of Palu, Bay of Palu. Okay, so I would like to give you an idea how we create the data generation and also inversion process. Okay, the data is generated by creating multiple scenarios. Okay, by using non-hydrostatic model that we show in the last two slide. Okay, and then the data set here, and then later on we use it to train the machine learning. Okay, and then this is some process. We are actually submitting this paper. This was founded didanai funded by uh, Kemendikbud Ristek. Yeah, and then how do we build the data? Actually, we creating multiple source of tsunami. Okay, multiple scenarios. We would like to guess it. Let's say 100 of scenarios of tsunami, and then from this initializations, which is actually random, and then we simulate it, and then we have from this simulation we get data set. Okay, this data set also later on we will use to train the algorithm of deep learning. Okay, for example, like this is one scenario. Okay, this is some initialization, scenario 19, and then we simulate it. After we simulate it, of course, we take the signal in Ciwanda, Kota Agung, Panjang, at 4 position. Okay, at this point we have some data set, we have some initialization, we have some signals. Okay, this is another scenarios for scenario 13. And then of course this we perform this approximately for 100 simulations. Okay, and then of course the data itself we are given into, we fit into the deep learning model, and then we use two model here. Is actually LSTM and bidirectional LSTM. The most accurate one actually we got a correlation for approximately 0.9 with the RMSA or error approximately like 19 centimeter. Okay, this is the error that we got up to now, and then we apply it with the real data. Actually, here is actually we introduce two approach. First one is actually non-parametric, and the other one is actually parametric inversions. Okay, then we got let's say similar with the event itself. Okay, because after the tsunami of 2018 here, it is collapsed in these directions. Okay, it is all by using deep learning we can guess actually the initialization maybe can be approximated by using the following shape like here. Okay, and okay, the last one, the last application is actually is not a wave. Okay, but it's just quite similar that uh, we use. Okay, this is AI based electricity forecasting system. Okay, so electricity company, this is based on real projects on from industry. In this case, is electricity company. So when you see, okay, when tomorrow is raining, okay, tomorrow raining uh, will rain, let's say. So most probably people in Jakarta, let's say, people in Jakarta most probably will turn off the air conditioning. Okay, the air conditioning is one of, let's say, device that needs the electricity the most in the let's say a house. Okay, so we would like to know, actually we would like to know which weather parameter that significantly affect the electricity here. For example, here, okay, which weather parameter that strongly affecting the electricity load, and then how the weather parameter distributed spatially when affecting an electricity load. So this is the first 2 point is actually more to the data science. Okay, this is that exploratory data. Okay, data explorations. And then the third one is actually more to the AI. Can we design, after we do some exploration, can we design the electricity load forecasting based on weather and then of course based on customer behavior. Okay, and then this is the second year. Last year we produced this software. Okay, we call it as Elec4 electricity forecasting. This is specially designed for electricity company in Indonesia. Okay, but this is still a prototype. But okay, to give you an idea, this is what we explore actually. We are now during pandemic. Okay, still in pandemic, unfortunately, in COVID-19 since let's say March 2020. Okay, so this is actually the study case in Bali. Okay, approximately the daily electricity load is actually approximately 900 sorry 600 megawatt per day. Okay, and then after the pandemic it is decreasing. Okay, let's say approximately 500 because there are lockdown and then ppkm, etc. Okay, and then we analyze it. This is more to the data explorations. We would like to know how is the behavior of the people during Monday until Sunday. Okay, because this is in Bali, it is quite the same. Okay, in Sunday there is a little bit decreasing of the use of electricity load. So in Bali every day is holiday. Okay, in Jakarta it is quite significant. Sunday and Saturday and Sunday it is dropping quite extensively. Okay, for Saturday and Sunday, but in Bali it is approximately the same. And this is actually daily use in Bali pre-pandemic and then during the pandemic. Okay, but now we would like to explore, actually, sorry, we would like to explore we would like to explore the, let's say, possibility, which we would like to explore which weather parameter that affecting electricity load consumption. Okay, so this one we actually fit in simply by qualitatively. We are plotting the blue one is actually electricity load, and then the red one is actually temperature. We can see it clearly here. The temperature and then the electricity load is quite related, let's say. Okay, and then the second one with the solar radiation. Okay, solar radiation, and then we calculate the correlation itself. This one is quite high. With the solar radiation, we got the correlation coefficient is 0.4, and then for the wind speed, we got negative correlation. Okay, so when the wind is blowing, uh, and when the electricity load tend to lower. Okay, so it has negative correlations. And then other parameter like rain rate, pressure, and then relative humidity. And then we have these tables. Okay, we have these tables. So this is actually weather parameter and then correlation coefficient that we have for the case in Bali Island. So not only per point, we also explore how is the correlation related spatially. We call it as a spatial correlations. Okay, and then here, because solar radiation is also this is uniform. Okay, therefore we got the uniform values between 0.44 until 0.545. But for the wind itself, okay, it is actually it is not quite large, but it is quite small, 0.13. And then for other parameter like net long wave, and then temperature is quite high here, 0.72. This is quite high correlated with the electricity load. And then other parameter like total precipitation and then rain rate. Okay, now we will see the accuracy. Okay, this is by using this is forecast by using bidirectional LSTM. Okay, but the input itself is actually parameter, a weather parameter that has high correlation with the electricity load. And then now here we have 4 scenarios. First of all, of course, to predict during pandemic, the electricity load during pandemic, it's quite different than predicting the electricity before pandemic. Let's say 2019. Okay, so we are playing, let's say, playing with the input of the data. It is actually concluded that the most accurate one is actually scenario 3. So we use data during pandemic to be used to forecast during pandemic. Okay, if we use the whole data, if we use the whole data like this one, all available data, it produces less accurate data, less accurate prediction. Okay, the number 3 is actually the most best one, let's say, to forecast 5 days ahead. Okay, we obtain correlation coefficient of 0.97, and then the MAPE. Okay, MAPE is mean absolute percentage error. Okay, it is about 2.6% error, and then the result is something like this. Okay, so approximately we are working on these projects, both from industry and also for research project with students here. Most of them is bachelor students from informatics. Okay, these are some publications, either proceedings, paper, and also intellectual property. In this case, is haki. In Indonesia, we call it haki. Okay, this is actually software. Okay, that's it, I guess, for my presentation, Pak Putu. Approximately.
Okay, thank you, Pak Didi. 45 minutes.
45
Yes.
minutes.
Yes, we have a
Okay.
15 minutes at least,
Yeah.
guys. So do you have any questions for the presentations from Pak Didi? So please welcome. Do you have any questions? Yes, Muhammad Dafa, you have a questions.
Okay.
Assalamualaikum, sir.
Dafa.
Yeah.
Permission, sir, I have a
Waalaikumsalam.
question.
Yes, Dafa.
So what I learned from this presentation is that to make a simulation much more faster and takes less time than before, we use first a simulation, that then we use deep learning or machine learning to train the model from the simulation, so we can get a faster result with less time. Is it, what does it mean, sir, from this presentation?
Okay. Yes. I will try to go to my slide. Okay, I understand what you are. So usually, okay. Thank you, Dava, for the questions. So usually, okay, conventional way is actually we do the forecasting. Forecasting is actually by using simulation. Okay, what we actually simulate is actually this equation. Let's say something like this. Okay, so this is actually energy balance equation. So we simulate the propagation of wave energy spatially. Okay, the evolutions of this energy we simulate by using these equations. Okay, this is actually it's quite large. It is quite require heavy computing. Okay, it is quite costly. Usually people do it on a cluster or supercomputer. Okay, but we would like to make something that is more efficient, let's say. So we are trying. Okay, here therefore I explain to you what is regression. Okay, the regression is there is a function, there is a input. Okay, and then we would like to guess an output. It is, and then this algorithm is actually, this relation is built by using machine learning, and then you are actually later on we produce the train deep learning. Is actually weight matrix. Okay, matrix bobot ya, yang kita produksi adalah situ. But this one, okay, we are trying to replace this process by simulating a given wind speed, and then we obtain wave height. Okay, but this process is actually we first of all we build data by using simulation. This is the most costly one, and then we got the data set, and then the data set itself we train into the deep learning, and then the deep learning later on it will automatically, it will download forecasted wind speed, and then automatically, because this is already trained, okay, automatically produce a wave in this project. So the result is something like this. Okay, so this software is actually based on bidirectional LSTM. Okay, for predicting the wave, we use a bidirectional LSTM, but for producing peak period, something like it, in the second plot, we use ADA-boost. Okay, sorry, XG-boost. Okay, XG-boost. We use XG-boost because bidirectional LSTM is not quite good in predicting this type of data. Let's say that's maybe my explanations. Okay.
Yeah. Okay. Thank you. Have any questions? Maybe one more question. One more question. One more questions maybe. Okay. Okay. So so if there are any questions, so maybe Pak Didit, can you have any what we can talk about? Any problems
Suggestion.
that is, oh yes, open problem or suggestions that for the students, that what they need to explore if they need to study this topic.
Okay. Maybe okay. Since this is a open problem, okay. What I'm saying is actually I'm not an expert at all in the electricity load. Okay, I'm not an expert at all when we are given the projects in 2020. I do not know anything about the electricity load. Okay, but I know the knowledge, of course, and then we need to solve this problem by using the knowledge that we have in informatics and in mathematics. So basically, what you are, can you guess? Can you cook up some problems related with optimization? Let's say, what type of forecasting you can apply to this type of, let's say, uh, this is machine learning. What type of problem, and then what type of possible problem that you can solve by using similar, let's say, similar idea in these three cases. That's maybe the open problem. Okay, can you cook up problem related with optimization, forecasting, but using the same analogy that that I show you to you in these three cases.
Okay. Okay. I think that's the good open problem. So I hope that you students can make an ASI. I think that you need to consider about the technology, right? But it did. So how the machine learning, how maybe the benefit, or maybe the similar similar process that Pak Didit shown before. Okay, so I hope that's I think that's all for the presentation. Yeah. Okay, so thank you Pak Didit again. Thank you Pak Didit, and I hope
Thank you.
actually I have want to show something. This is the
Okay.
certificate of appreciations. Okay.
Okay.
So yeah, thank you very much for for your time to discuss just in 1 hour. I think 1 hour is very
Yes.
enough.
Okay.
Okay, so thank you. So I think I hope
Yeah.
I need all of
Thank you
you
very
can
much.
welcome. Open the camera on. So I need to stop share first. Okay, or I don't know, something like this. Okay, I hope that all of you can open the camera. I need to take a picture. Okay. Okay, Bima, Rifki. So it's suddenly right. You need to prepare. Okay. Okay. Just in minute. Okay. It's quite. Sorry. Wait a minute. I need to save this first. Okay, save. Okay, are you ready, guys? Kevin, Rifki, Olaza, Sofian, can you please open your camera? So actually, we have one SI after this one. Okay, so the problem that as what Pak Didit say, that you need to consider what the actually the maybe another applications. Okay, it's similar things as Pak Didit presented today. Okay, so the essay, and then you can submit your essay in DLMS. Okay, I already make one topic especially for this class, for the only for the international class. You can upload this maybe in 1 week. Okay. Okay, Sofian Olaza, sorry, Rifki Aulia, can you please open camera, or maybe you are not right there or something? Okay, I just, yeah. Okay, Rifki Olaza. Okay, so I need to count into 3. 1. Okay, big smile. 1, 2, 3. Okay, so I need to yeah, I need to sit first. Okay. Before it's gone. Okay, and okay, I think that's all. Okay, thank you very much, Pak Didit, and for the student, thank you very much for your times. I hope that you can take the advantage of these courses. Okay, and we can and I hope that we can invite another speaker for the next weeks, and you can join as usual. Okay, I think that's all for today. Thank you very much for your time. See you again, Pak Didit. Happy
Thank you.
trip. Happy trip and safe. Okay,
Yeah.
thank you very much. Bye
Okay,
bye.
thank
Goodbye.
you.
Yeah, I need to close
Goodbye.
this session. Thank you. Bye bye.
Okay. Okay, thank you, Pak Putu.